Welcome to Euclide Academy, and in this presentation we want to talk about the Brownian motion, and this theory is closely related to the kinetic theory of matter as well as the particle theory. So in this lesson we want to understand Brownian motion and how that explains the movement of particles which are in a fluid or in a gas. So what I'm going to look at in this presentation, we're going to look at the theoretical explanation of Brownian motion, the applications of Brownian motion in the kinetic theory of gases and how they connect, and then we're going to wrap it up from there. So let's talk about Brownian motion. What is it and what does it mean? So Brownian motion basically talks about the movement of particles. We talked about the kinetic theory of matter and how it explains that matter is made up of small particles, and it talked about the three concepts that matter has got these particles which are in random motion and they've got spaces in them. Now, Robert Brown, who was a Scottish botanist, actually discovered that there is some kind of movement of particles when they have been suspended in a fluid. And that movement is actually caused by the particles of the fluid. So the movement is due to the collisions of the surrounding molecules. So if you put some pollen onto a fluid, you'll notice that the movement of the pollen is basically due to the movement of the invisible water molecules which are colliding with the pollen that you've put onto that water or that fluid. So this is the theory behind Brownian motion, that actually the movement of particles are caused about by the collisions of the particles with the particles of a gas or a fluid that those particles have found themselves in. So what's the significance of Brownian motion? So Brownian motion has got an important implication in different fields of science, ranging from chemistry, physics, and biology. And basically you have a lot of theory based on Brownian motion and a lot of concepts that you have to explain, and they'll make sense if you actually understand this theory of Brownian motion or concept. So as said, this theory was discovered by the Scottish botanist Robert Brown. And this theory is basically very important. It helps in a lot of scientific fields, from chemistry, biology to physics fields, and the theoretical explanation of the Brownian motion is what we basically just talked about, that the particles in the fluid or the gas actually affect the particles, that the motion of the particles that have the motion of particles in them. So the motion of particles in a fluid or a gas will be determined by the collisions between the particles and the fluid or gas molecules. So there is the random motion of particles in the fluid is being caused about by the collisions between the particles and the fluid or gas molecules, and the randomness of Brownian motion is as a result of the random collisions between the particles and the fluid of gas molecules. So that explains the theory behind the Brownian motion, which explains that every particle, the movement of the particles that we can put in a fluid or a gas would be dependent upon the collisions of those particles with the molecules of that particular fluid or that particular gas. So basically we're talking about these collisions that the molecules are going to have and with the particles that will determine the movement. When you talk about the movement, of course we're talking about the velocity and we're talking about the randomness. So Brownian motion could be applied to a lot of different concepts, to the thermodynamics, and this is what we're going to talk about in the next lesson, and we won't spend much time on that. But rather what I'm going to talk about is the connection between Brownian motion and the kinetic theory of gases. So we talked about the kinetic theory of gases in the previous lesson, where we mentioned that it basically mentions how matter is made up of particles, and these particles are in random motion, and they have got spaces in between them. So there is a relation between Brownian motion and the kinetic theory of gases. The random motion of particles due to Brownian motion is an example of actually the kinetic theory of gases in action, which talks about matter having these particles which are in constant motion. As kinetic theory, we mentioned that these particles are actually moving, they have kinetic energy, so they are actually moving. And Brownian motion also explains that the particles are colliding, and they are moving in random direction. So the random motion of the particles due to Brownian motion actually could be connected to the kinetic theory of gases, which says that these particles are in random motion and they are constantly moving. So an example could be when we explain the theory that they are exerted by a gas onto the the walls of the container. It could be due to the collision of the molecules of the gas with the walls of the, so which is the kinetic theory of gases, which of course could be related, could be just explained nearly the same as the kinetic theory of gases. We could actually get these concepts and just see this meaning. So we see the key word is kinetic, and which means that these particles, these molecules, they are in constant random motion, and we can have these molecules hitting the walls of the container to create pressure or to exert pressure, and that is the kinetic theory of gases. But when we talk about the kinetic theory of matter, we're talking about these molecules just having kinetic energy. So when we talk about gases, we're actually adding pressure to it, and it will be an interesting topic that we can discuss, or will be discussed in the next presentation coming in the next weeks. So that is on Brownian motion and how it is connected to the kinetic theory of gases, or the kinetic theory of matter, whichever one you want to use there. The idea or the theoretical explanation basically is just the sum. So Brownian motion basically tells us that the particles are actually, which have been put in a fluid, their movement will be affected by the molecules of that fluid or gas due to them colliding with each other. So that is the Brownian motion, and then we can talk about just the conclusion on this. So Brownian motion is actually a very important concept, and you see this concept taking some time to look at different ideas or different concepts which are closely related to the Brownian motion. And one of those concepts we talked about is the kinetic theory of gases, and basically we'll talk about the gas laws as well as the application of Brownian motion to thermodynamics. We'll talk about, when we talk about thermophysics, and the idea starts on such concepts as the Brownian motion, which basically just builds in us the theory behind these scientific concepts. And we'll find more and more of these concepts to be clearer as we base our understanding on Brownian motion. So Brownian motion gives us that explanation of the random motion of particles, could be in a fluid or a gas, and we can base our understanding on of different theories such as thermodynamics, the kinetic theory of gases, based connecting it to the Brownian motion or basing it on Brownian motion. So it has important applications in variety of fields, which is physics, chemistry, as well as biology. So that is on Brownian motion, and in conclusion, wrapping it up, is that it talks about how the movement of particles are actually affected by the collision of the particles with the molecules of a fluid or a gas, and the randomness is basically due to the collision. Let's look at some example past paper questions that are related to Brownian motion and see how we can answer them. So the question says, Brownian motion provides evidence for particle theory. Question 1, give an example of how Brownian motion can be demonstrated. And question number 2, explain how Brownian motion provides evidence for particle theory. Use the B part, using ideas about particles, explain how the air inside a container exerts pressure. So you can already see how we can use Brownian motion to answer these questions, or the concepts we just discussed to answer some of these questions. So this question talks about particle theory, and we talk about the kinetic theory of gases, kinetic theory of matter, and thermodynamics, and how that can be related to Brownian motion. So particle theory is closely related to the kinetic theory of gases or the kinetic theory of matter. So basically they all try to explain the same thing, but they just do it in different ways, and we can actually just use what we've actually discussed to answer this question. So this question was in the Igcse physics past paper, which we're going to revise. So let's try to answer the first question. Give an example of how Brownian motion can be demonstrated. So one way in which we can use Brownian motion or demonstrate Brownian motion is by using pouring grains on water. The second way could be dust particles in air. So how we can do it is we can demonstrate by using a microscope to observe the random movement of these particles, which we are going to suspend them in a liquid such as pollen being put in water, and then you record the movement of these particles and observe what is happening by using the microscope's focus and lighting. So this is how we can demonstrate Brownian motion, and you can actually use dust particles in air. The second question, explain how Brownian motion provides evidence for particle theory. So how we could give the explanation is that we have seen how Brownian motion gives us the evidence or the idea that actually particles are in random motion, and they are actually caused to change direction by hitting the invisible molecules of fluid or gases. So this is consistent with the idea that matter is made up of small particles which can have two properties, or these properties, mass and velocity, and which means that these properties actually determine how the particles will move and interact with each other. So we can actually focus on 3 points to explain this. Number one is that the fluid or the particles suspended in the fluid or gas exhibit randomness due to constant collisions with the particles or the molecules of the gas or the fluid. And number two, that they are made up of tiny molecules, which are these molecules are actually tiny and are actually invisible, but can have these properties as mass and velocity. So 3 points: randomness, they can be tiny and invisible. So this is how we can explain that Brownian motion has got the evidence for particle theory, because these are the 3 ideas of particle theory. The last question says, using ideas about particles, explain how the air inside a container exerts pressure. So we can actually explain this, that the particles are actually, since they're in random motion, they're hitting the walls of the container and they're making a force. and pressure is force on an area. So this actually creates or exerts pressure on the walls of that container. So that is how pressure is actually created, because these particles are in random motion and they're hitting the walls of the container, and pressure is the force on an area. So that is how we would explain the last point. The wording and everything doesn't really matter. You just have to use the keywords or the key points that actually the randomness of the particles are actually hit, or the particles moving randomly are hitting walls of the container, as a result exerting pressure, which is just a force on an area. So that is it with this lesson, this presentation on Brownian motion. And all in all, hope you've gotten an understanding of what Brownian motion is all about and the theories it is connected to: the kinetic theory of gases, the particle theory, the kinetic theory of matter, and how basically it talks about matter having these small particles, which the movement of the particles being caused about the particles colliding with other particles or molecules of other substances such as fluids or gases. So that is about the Brownian motion, and we'll see you in the next lesson.